Welcome to the entire Wikipedia page for rope. A rope is a group of yarns, plies, or strands that are twisted or braided together into a larger and stronger form. Ropes have tensile strength and so can be used for dragging and lifting, but are too flexible to provide compressive strength. As a result, they cannot be used for pushing or similar compressive applications. The rope is thicker and stronger than similarly constructed cord, line, wing, string, and twine. Fiber rope is made from fiber, whereas wire rope is made from wire. Construction. Rope may be constructed of any long, stringy, fibrous material, but generally is constructed of certain natural or synthetic fibers. Synthetic fiber ropes are significantly stronger from their natural fiber counterparts, but also possess certain disadvantages, including slipperiness. Common natural fibers for rope are manila hemp, feathers, linen, cotton, core, jute, straw, and sisal. Synthetic fibers in use for rope making include polypropylene, nylon, polyesters such as PET, LCP, or Vectran, polyethylene such as Dyneema and Spectra, aramids like Twaron, Technora, and Kevlar, and acrylics like Dralon. Some ropes are constructed of mixtures of several fibers or use copolymer fibers. Wire rope is made of steel or other alloys. Ropes have been constructed of other fibrous materials such as silk, wool, and hair, but such ropes are not generally available. Rayon is a regenerated fiber used to make decorative rope. The twist of the strands in a twisted or braided rope serves not only to keep a rope together, but enables the rope to more evenly distribute the tension among the several strands. Without any twist in the rope, the shortest strands would be always supporting a much higher proportion of the total load. Usage. Rope is of paramount importance in fields such as construction, seafaring, exploration, sports, theater, and communications, and has been used since prehistoric time. To fasten rope, many types of knots have been invented for countless uses. Citation needed. Pulleys redirect the pulling force to another direction and can create a mechanical advantage so that multiple strands of rope share a load and multiply the force applied to each end. Winches and capstans are machines designed to pull rope. Rock climbing ropes. The modern sport of rock climbing uses so-called dynamic rope, which stretches under load in an elastic manner to absorb the energy required to arrest a person in free fall without generating forces high enough to injure them. Such ropes normally use a kern mantle construction, as described below. Static ropes, used for example in caving, rappelling, and rescue applications, are designed for minimal stretch. They are not designed to arrest free falls. The UIAA, in concert with the CEN, sets rope climbing standards and oversees testing. Any rope bearing a GUIANA or CE certification tag is suitable for climbing. Despite the hundreds of thousands of falls climbers suffer every year, there are few recorded instances of a rope breaking in a fall. The cases that do are often attributable to previous damage to or contamination of the rope. Climbing ropes, however, do cut easily when under load. Keeping them away from sharp rock edges is imperative. Rock climbing ropes come together with either a destination for single, double, or twin use. A single rope is the most common and is intended to be used by itself as a single strand. Single ropes range in thickness from 9 to 11 millimeters. Smaller ropes are lighter but wear out faster. Double ropes are thinner ropes, usually 9 millimeters and under, and are intended for use as a pair. These ropes offer a greater margin for security against cutting, since it is unlikely that both ropes will be cut, but they complicate belaying and leading. Double ropes are usually reserved for ice and mixed climbing, where there is need for 2 ropes to rappel or abseil. They are also popular among traditional climbers, particularly in the UK, due to the ability to clip to each rope into alternating pieces of protection, allowing the ropes to stay straighter and hence reduce rope drag. Twin ropes are not to be confused with doubles. When using twin ropes, both ropes are clipped into the same piece of protection, treating the two as a single strand. This would be favorable in a situation where there is a high chance of the rope being cut. However, new, lighter weight ropes with greater safety have virtually replaced this type of rope. The butterfly coil is a method of carrying a rope used by climbers where the rope remains attached to the climber, ready to be uncoiled at a short notice. Another method of carrying a rope is the alpine coil. Aerial rope. Rope is also an aerial acrobatic circus skill where a performer makes artistic figures on a vertical suspended rope. Tricks performed on the rope are, for example, drops, rolls, and hangs. They must also be strong. See also corde à lissé. History. The use of ropes for hunting, pulling, fastening, attaching, carrying, lifting, and climbing dates back to prehistoric times. It is likely that the earliest ropes were naturally occurring lengths of plant fiber, such as vines, followed soon by the first attempts at twisting and braiding these strands together to form the first proper ropes in the modern sense of the word. Impressions of cordage that can be found on fired clay provide evidence of string and rope-making technology in Europe dating back 28,000 years. Fossilized fragments of probably two-ply laid rope of about 7 millimeter diameter were found in one of the caves at Lascaux, dating to approximately 15,000 BC. The ancient Egyptians were probably the first civilization to develop special tools to make rope. Egyptian ropes date back to 4,000 and 3,500 BC, and was generally made of water reed fibers. Other rope in antiquity was made from the fibers of date palms, flax, grass, papyrus, leather, or animal hair. The use of such ropes, pulled by thousands of workers, allowed the Egyptians to move the heavy stones required to build their monuments. Starting from approximately 2800 BC, rope made of hemp fibers was in use in China. Rope and the craft of rope making spread throughout Asia, India, and Europe over the next several thousand years. In the Middle Ages, from the 13th to 18th century, from the British Isles to Italy, ropes were constructed in rope walks, very long buildings where strands the full length of rope were spread out and then laid up or twisted together to form the rope. The cable length was thus set by the length of the available rope walk. This is related to the unit of length termed cable length. This allowed for long ropes up to 300 yards or longer to be made. These long ropes were necessary in shipping, as short ropes would require splicing to make them long enough for use in sheets and halyards. The strongest form of splicing is the short splice, which doubles the cross-sectional area of the rope at the area of the splice, which would cause problems in the running line through pulleys. Any splices narrow enough to maintain smooth running would be less able to support the required height. Citation needed. Leonardo da Vinci drew sketches of a concept for a rope-making machine, but it was never built. Nevertheless, remarkable feats of construction were accomplished without advanced technology. In 1856, Domenico Fontana erected the 372-ton obelisk on Rome's St. Peter's Square, with a concerted effort of 900 men, 75 horses, and countless pulleys and meters of rope. By the late 18th century, several working machines had been built and patented. Some rope is still made from natural fibers, such as core and sisal. But despite the dominance of synthetic fibers such as nylon and polypropylene, which have become increasingly popular since the 1950s. Styles of rope construction. Laid rope, also called twisted rope, is the historically prevalent form of rope. At least in modern Western history, common twisted rope generally consists of 3 stands and is normally right-laid or given a right-handed twist. The ISO 2 standard uses the uppercase letters S and Z to indicate 2 possible directions of twist, as suggested by the direction of the slant of the central positions or portions of these 2 letters. The handedness of the twist is the direction of the twists as they progress away from an observer. Thus, Z rope is said to be right-handed and S twist is said to be left-handed. Twisted ropes are built up in 3 steps. First, fibers are gathered and spun into yarns. A number of these yarns are then formed into strands by twisting. The strands are then twisted together to lay the rope. The twist of yarn is opposite to that of the strand, and that in turn is opposite to that of the rope. It is this counter twist introduced with each successive operation which holds the final rope together as a stable, unified object. Traditionally, a three-strand laid rope is called a plain or hawser laid, a four-strand rope is called a shroud laid, and a larger rope formed by counter-twisting three or more multi-strand ropes together is called a cable laid. One property of laid rope is partial untwisting when used. This can cause spinning of suspended loads, or stretching, kinking, or hackling of the rope itself. An additional drawback of twisted construction is that every fiber that is exposed to abrasion numerous times along the length of the rope. This means that the rope can degrade to numerous inch-long fiber fragments, which is not easily visually detected. Citation needed. Twisted ropes have a preferred direction for coiling. Normal right-hand rope should be coiled clockwise to prevent kinking. Coiling this way imparts a twist to the rope. Rope of this type must be bound at its ends by some means to prevent untwisting. Braided rope. While rope may be made from three or more strands, modern braided rope consists of a braided or tubular jacket over strands of fiber. These may also be braided. Some forms of braided rope with untwisted cores have a particular advantage. They do not impart an additional twisting force when they are stressed. The lack of added twisting force is an advantage when a load is freely suspended. When a rope is used for rappelling or to suspend an arborist, other specialized cores reduce the shock from arresting a fall when used as part of a personal or group safety system. Braided ropes are generally made from nylon, polyester, polypropylene, or high-performance fibers such as high-modulus polyethylene and aramide. Nylon is chosen for its strength and elastic stretch properties. However, nylon absorbs water and is 10 to 15% weaker when wet. Polyester is about 90% as strong as nylon, but stretches under load and is not affected by water. It has somewhat better UV resistance and is more abrasion resistant. Polypropylene is preferred for low cost and lightweight. It floats on water, but has limited resistance to UV light, is susceptible to friction, and has a poor heat resistance. Braided ropes and objects like garden hoses, fiber optic, or coaxial cables that have no lay or inherent twist uncoil better if each alternate loop is twisted in the opposite direction, such as in figure-8 coils, where the twist reverses regularly and essentially cancels out. Single braid consists of a number of strands, 8 or 12 being typical, braided into a circular pattern with half of the strands going clockwise and the other half going anti-clockwise. These strands can interlock either with either twill or plain weave. The central void may be large or small. In the former case, the term hollow braid is sometimes preferred. Double braid, also called braid-on-braid, consists of an inner braid filling the central void and an outer braid that may be of the same or different material. Often, the inner braid fiber is chosen for strength, while the outer braid fiber is chosen for abrasion resistance. In solid braid, the strands all travel the same direction, clockwise or anti-clockwise, and alternate between forming the outside of the rope and the interior. This construction is popular for the general purpose utility rope, but rare in specialized high-performance line. Kern mantle has a core, kern, of long twisted fibers in the center, with a braided outer sheath of mantle of woven fibers. The kern provides most of the strength, about 70%, while the mantle protects the kern and determines the handling properties of the rope, as in how easy it is to hold, to tie knots in, and so on. In dynamic climbing line, core fibers are usually twisted and chopped into shorter lengths, which makes the rope more elastic. Static kern mantle ropes are made with untwisted core fibers and tighter braid, which causes them to be stiffer in addition to limiting the stretch. Other types. Plaited rope is made by braiding twisted strands and is also called square braid. It is not as round as twisted rope and coarser to the touch. It is less prone to kinking than twisted rope and, depending on the material, very flexible and therefore easy to handle and knot. This construction exposes all fibers as well, with the same drawbacks as described above. Braid rope is a combination of braided and plaited, a non-rotating alternative to laid three-strand ropes. Due to its excellent energy absorption characteristics, it is often used by arborists. It is also the popular rope for anchoring and can be used as mooring warps. This type of construction was pioneered by Yale Cordage. Endless winding rope is made by winding single strands of high-performance yarns around two end terminations until the desired break strength or stiffness has been reached. This type of rope, often specified as cable to make the difference between a braided or twined construction, has the advantage of having no construction stress, as in the case with above constructions. Endless winding is pioneered by Smart Rigging and Fibermax. Safe and proper rope handling. Rope made from hemp, cotton, or nylon is generally stored in a cool, dry place for proper storage. To prevent kinking, it is usually coiled. To prevent fraying or unraveling, the ends of a rope are bound with twine or whipping, tape, or heat shrink tubing. The ends of plastic fiber ropes are often melted and fused solid. However, the rope and knotting expert Geoffrey Budworth warns against this practice thus. Sealing rope ends this way is lazy and dangerous. A tugboat operator once sliced the palm of his hand open down to the sinews after the hardened and obviously sharp end of a rope had been heat sealed pulled through his grasp. There is no substitute for a properly made whipping. If a load-bearing rope gets sharp or sudden jolt or the rope shows signs of deteriorating, it is recommended that the rope be replaced immediately and should be discarded or only used for non-load-bearing tasks. The average rope lifespan is 5 years. Serious inspection should be given to the line after that point. Citation needed. However, the use to which a rope is put affects frequency of inspection. Rope used in mission-critical applications, such as mooring lines or running rigging, should be regularly inspected on a much shorter timescale than this, and rope used in life-critical applications, such as mountain climbing, should be inspected on a far more frequent basis, up to and including before each use. When preparing for a climb, it is important to stack the rope on the ground or a tarp and check for any dead spots. Citation needed. Avoid stepping on rope, as this might force tiny pieces of rock through the sheath, which can eventually deteriorate the core of the rope. Ropes may be flemished into coils on deck for safety and presentation and tidiness, as shown in the picture. Citation needed. Many kinds of filaments in ropes are weakened by acids or other corrosive liquids or solvents, and high temperatures. Such damage is treacherous because it is often hard to tell by eye. Rope damaged in such ways is dangerous to use. Ropes, therefore, should be kept away from all kinds of solvents and corrosive acids, alkalis, and oxidizing agents. In addition, ropes should avoid sudden load, as a shock can destroy a rope easily. Any operation of ropes should obey the principle of safe working load, which is usually much less than its ultimate strength. The rope should be replaced immediately if any evidences of shock load have been found. A rope under tension, particularly if it has a great deal of elasticity, can be very hazardous if it should part, snapping backward and potentially causing grave or lethal injury to people or damage to objects in its path. There are occasions when it is proper to cut a taut rope under load, but this should only be done when necessary and only with great forethought and preparation for the potential consequences. Line. Rope refers to the manufactured material. Once rope is purposely sized, cut, spliced, or simply assigned a function, the result is referred to as a line, especially in nautical usage. Sail control lines are mainly referred to as sheets. For example, jib sheet. A halyard, for example, is a line used to raise and lower a sail, and is typically made of a length of rope with a shackle attached at one end. Other examples include clothesline, chalk line, anchor line, stern line, fishing line, marline, and so on. See also Cordage Institute, FID, flogging, physical restraint, hanging, Hauser, International Year of Natural Fibers 2009, jump rope or rope skipping, knot, rigging, rope bondage, rope bridge, rope lock, in theater fly system, rope splicing, rope work, sheet, sailing, single rope technique, tightrope walking, and whipped rope. Holy God, I just recorded that.